Hi everyone. Today we will be discussing about an important data center topic, which is the design and calculations. Basically, if you are working on a data center, we need to know the power requirements and the calculations, which provide how the data center is going to shape up in the future. Like what is the total requirements, what power is required for the data center, an important concept, redundancy concept, the calculation of future load, and we need to be sure about underestimating the power requirements. If you decide and design for a data center and you underestimate the power requirements, like if you need 10 uh, 10,000 kilowatt data center, but you design something which needs which is for 8,000 kilowatt, then future power disruptions is very likely. So you will end up having issues. Similarly, overestimating what if you overestimate the power requirements, and if a requirement for 10,000 kilowatt, but you end up doing 15,000, then you have excessive initial costs, obviously, and then higher maintenance. So if you have taken a facility which is going to be empty, about 30%, if the facility is empty for an year or so, you are wasting the maintenance cost, the utilities, the power bills. That's an extra cost. And the key components of the data center we discussed were the network infrastructure, storage infrastructure, and the computing resources. I will be discussing also about the power usage chart for the data centers. Where does the power go in the data center? That's the most likely question. People do tend to know in these initial stages before they start building up the data center, because we need to show the total power consumption, power usage, where is the power going. So critical loads 36%, cooling load is about 40 to 50%, UPS inefficiency, battery is 11 to 15%, lighting is 3 to 5%. Cooling, if we notice in data centers, cooling and the HVAC part of it uses majority of the power utilization in a data center, because the amount of energy used to cool the data center, keep it operational, to ensure minimum downtime and maximum uptime, so that we don't have any issues or interruptions. Critical loads take up 36 to 40% of the power. UPS battery takes about 11 to 15. I mentioned lighting takes 1 to 5 or even 10%. Typical data center design calculations. If we start the design from the scratch, this is critical. Designing from scratch, we need to assume any kind of size on the data center. Let us assume we have a data center. Hi everyone. Today we will dive into the electrical calculations required for setting up a data center, and we'll take an example. If we have a data center, suppose let's assume an area 2400 square feet, and it has about 100 racks, and we have to make a couple of design assumptions. If it has 2400 square feet, 100 racks, and we are using 100% DX cooling, that is compressors, obviously, create the table. So we need to make sure to list out the components of a rack first. So if we have 100 racks, we need to find out what one rack power usage is going to be. So if we consider Dell servers R450 models, and they have 500 watt rating, is 0.5 kilowatt, and you have storage array 1, storage array 2, let's assume 500 watts and 600 watts is 0.5 kilowatt and 0.6 kilowatt, and the total rack is, adding the server and the storage array power, is going to be 500 plus 500 plus 600. That's about 1600 watts, is 1.6 kilowatt, and we have for one rack 1.6 kilowatts. So for 100 racks, it's about 160 kilowatts for 100 racks. So 160 kilowatt is the design calculation for the power requirements for 100 racks. And we are calculating the next, number one, the total number of racks power required for one rack multiplied by total number of racks as the power for the racks serving housing the servers and the storage arrays. And then the next is a future load. If you're assuming a growth of about 20% growth, and keeping that in mind, we will have a critical load of 160, and we are adding a future load of 20%. Is 160 plus 32 kilowatt is 192 kilowatt, because you multiply 160 times 20 by 132, so is 192. 160 plus 32 is 192 kilowatt, and you have a peak power multiplier. It's 5%, so it's 1.05. You multiply 192 kilowatt times 1.05 is 201 kilowatt. So peak power adjustment between peak power adjustment is basically the peak power drawn with 1.05. It's the peak power drawn minus the future load. 201 minus 192 is 9 kilowatt is the peak power adjustment. So we have taken the future load calculation into account. And now, so once you have the rack power multiplied by number of racks, and then the future load having a peak power multiplier, and then you have the peak power adjustment. The next critical items which draw the power UPS load calculation. Let's assume our UPS efficiency is 80%. That is, we get out of 100 kilowatt, we get 80 kilowatt. So if you have a UPS input of 100 kilowatt, you're getting 80 kilowatt because of the 80% efficiency on the UPS. Power losses from batteries. If they're not charged, there's 20% power loss. We can estimate UPS and batteries is 20% plus 20% is about 40% total inefficiency. So final load calculations will include critical load 201 kilowatt, inefficiency factor 20 plus 20 is 40% of critical load. So 201 times 40% gives us 80.4 kilowatt. So that is the final load. So after the UPS, the next thing we consider is the lighting load calculations. And let's estimate about 4 watt per square feet. If it's about 2400 square footage of the space, so 4 watts into 2400 is 9600 watts, is 9.6 kilowatts. So we got the lighting load, we got the UPS, we got the racks, and we got the critical load. Now calculating the total load of critical, future load, peak power, UPS, battery, lighting. Total we have 160 kilowatt, 32 kilo. Critical load is 160 kilowatt. Future load is 32 kilowatt. Peak power 9 kilowatt. UPS and battery inefficiency 80.4 kilowatt. Lighting is 9.6. So total gives you about 290 kilowatt. So in other words, what is the energy required to cool 290 kilowatts of equipments of load? So the cooling efficiency, considering we have a DX system, completely compresses, so is 290 times 1 is 290 kilowatt. So you need 290 kilowatt of power to cool down 290 kilowatt of the power load. So total estimate now. So you got 290 and 290 for the cooling. Total estimate is component wise. Component critical load is 160 kilowatt, future load 32 kilowatt, adjustment for peak power draw 9 kilowatt, UPS battery inefficiency is 80.4 kilowatt, lighting is 9.6 kilowatt, cooling is 290 kilowatt. Total power required, you add up all these things, is 580 kilowatts. Total utility estimate is total power times 125%. To put into perspective, we are calculating these power requirements so that we can give it to the utility company that, hey, this is the total amount of power we are estimating for our facility, which might need for the systems and the operations to run seamlessly. But we also add, remember, we are adding 25% extra when we give it to the utility company. So utility estimation is total power times 125%. So it was 580 kilowatt times 125% gives us about 725 kilowatt. So we need 725 kilowatt of power to run 2400 square foot of space with 100 racks. So that's the total power calculations we have designed. So this is the electrical consumption. So we need to tell the utility company, hey guys, this is our requirement, 725 kilowatt for us to be able to run a 2400 square footage of data center space. And now we are adding generator calculations as well. That is the final concept. How big of a generator set we need to manage, the critical load, cooling load. 290 was the critical load. 290 times 1.3 is 377 kilowatt. That's the critical load. And cooling load, 290 times 1.55 is 450 kilowatt. So total 830 kilowatt is the size of the generator required. So in case of a power failure, then we need a generator of 830 kilowatt sizing to manage the data center until the power is restored. So generator calculations, you multiply the critical load by 1.3 times and cooling load by 1.55 times. And that gives us this total. If you add the two loads, we have a total size of the generator required, basically 830 kilowatts. So that should give us a brief idea and a basic design parameters. I'm going to put it on the side. You can see the calculations which I've written with my hand. So with this concept, we can actually adjust and add or remove the racks and the components as needed. And that gives us electrical load calculations for a data center. Thank you.